Alrighty, welcome to What the Heck is OAuth and OIDC. My name is Matt Raible. I'm a hick from the sticks. I grew up in the backwoods of Montana. No electricity, no running water. I had to walk 2 miles to the bus stop every day, and it felt like it was uphill both ways. I do live in Denver with my lovely wife Trish and my 2 awesome kids. They're now teenagers. The boy on the left there is actually taller than me now. He was here last year, but he's grown like 6 inches since then. I also have a middle child. His name is Hefe. This is a 1966 Volkswagen bus that I bought off eBay. And if you read my blog, ever since 2004, I thought he was going to be finished in 6 months. So I like to believe in things. I work for a company called Okta. How many people are developers? Most hands went up. Cool thing about Okta, we treat developers the same as we treat our customers. So if you'd like to go out for a drink, I can treat you like a customer, take you out to dinner, have a good time. So we provide a number of authentication standards. SAML is one of the popular ones. We also support OAuth 2 and OpenID Connect. And so I'll be talking about those today and hopefully explaining so there's little confusion when you leave the room. So how many people have heard of OAuth? Okay, so that's 90%. How many people have heard of OpenID Connect? Okay, it's most of the room, but less hands. How many people have written authentication from scratch? Okay, not very many. That's a good idea. How many have implemented OAuth, like built an OAuth server? Okay, we got a few of you. What about an OAuth client? Talks to an OAuth server, okay? All right, so I know a bit about you. Most people are Java developers, I'm assuming, but let's see if we have any .NET developers. Nobody? All right. Any Python developers? We got 2. And any Node developers? Okay, we got about 5. All right. So just trying to figure out who everyone is. So this will be an OAuth 2 overview. How many of you have a basic understanding of OAuth? I mean, you said you'd heard of it, but do you know what like a redirect URI and how that fits in? So who all knows that part of OAuth? Okay. And how many people would consider themselves an expert? Notice my hand didn't go up either. All right, so it's one of those things that you really have to experience, and then maybe you'll become an expert because there's so many different nuances. But we hope to talk about all the different terms today, and hopefully when you leave here it'll be clear. So let's start with a bit of history. When we started way back in the day with web authentication, this is like circa 2002, 2003, we had what's called basic authentication, and you might be familiar with this dialog, right? If you use basic authentication, it pops up a browser dialog. And basically what happened is a lot of customers were like, that's cool, but I really want to brand that login page. And so then we moved to form-based authentication. The problem with both of those is you're storing the user's information in your servers, right? And if you're using basic authentication, you're using like Apache or Nginx, chances are you're just storing that in a file. And so you might not even be doing password hashing or password encryption. So that can be, dangerous. And then what it moved on to was federated identity. This was created for a single sign-on. And there's basically 2 main players in federated identity. There's an identity provider and then a service provider. And often the service provider is just the application that you need to log into, and the IDP is a provider of the users. And so federated identity was made famous by SAML. SAML 2.0 was an OASIS standard that was released March 15th, 2005. It's a large spec, but the main 2 components are Authentication Request Protocol and the assertion, also called SAML assertions. And so the SAML 2.0 authentication protocol looks like this. Service provider goes to the user agent. There's a bit of redirecting. How many people are Okta customers? So there's a couple of you. What Okta has is Okta has a dashboard that you log into in the morning, and everything you need to access throughout the day is on that dashboard. So you might need Workday, to request some time off, or you might need Google Docs to, write a blog post, or all these different features. Well, most of those use SAML. When you click on that, it does a redirect. It logs you into, the service provider, and, that's a SAML assertion. So, it starts with something like Okta, right? You click on continue, and then there's a little assertion on the other side, and then it comes back and gives you your actual data. And it's all XML, so not very developer friendly, right? We moved on from this. So SAML is basically a session cookie in your browser that gives you access to web apps. It's limited in the kinds of devices and scenarios you might want to use it for. And so a lot has changed since 2005. It made sense in 2005. And now there's a lot of confusion. If you search on OAuth and try to figure stuff out, there's lots of jargon and lots of incorrect info. There's even an answer on Stack Overflow that probably gets a whole lot of high rankings, but then there's a comment on there that says, hey, you're wrong. Here's my blog post that explains what's right. And you go to that blog post and you read through that and it sounds good, and then at the bottom there's another comment that says, you're wrong. Here's what's right, right? So that can be very confusing. And part of the problem is just it's not very clear in the spec itself, in the OAuth spec, versus like HTTP spec. No one ever argues about that, right? It's pretty much laid out and it works well. So I'm trying to make it less intimidating, less confusing today. So identity use cases in 2006 when SAML was popular was basically a simple login, right? You had a basic form and cookies. There was no single sign-on across sites that you were trying to do. There was no mobile apps. There was no delegated authorization. The iPhone wasn't even released until 2007, June 29th. And so this gave rise to the delegated authorization problem, which is how can you give a website access to your data without giving it your password? So back in 2005, 2006, this is what it looked like. Are your friends already on Yelp? If you use LinkedIn, you probably had a similar form that would pop up after you actually signed in. And it says, give me your email service, give me your email address, and give me your email password. And so most people at the time were probably fine with it, right? But there's really no guarantee that Yelp or LinkedIn didn't keep your password. You're typing it in plain text, right? They can save it, and then they can keep checking your contacts, or maybe they could even send an email on your behalf, right? But there's nothing in here that prevents them from doing that, so obviously that's a bad thing to do, because if someone can log into your Gmail, that means they can go to your bank account and say, I forgot my password, and they can read, that, reset your password, get your money. Side note, banks are the ones that still haven't adopted OAuth. Everyone else, pretty much on game, but not banks. So how many people have seen one of these? Right, log in with Facebook. That's basically OAuth. Delegated authorization, inspired OAuth. And so you can think of OAuth like hotel key cards, but for apps. So if you have a hotel key card, you have access to the various rooms, maybe the gym, maybe your room at the hotel, but that lock or that thing that you give your key to has really no idea who you are. There's no identity associated with it. They just know that you have access to it. And so how do you get a hotel key card? You go to the front desk and you authenticate, right? You give some sort of ID to that front desk. Maybe it's a passport, maybe it's your driver's license, and they say, okay, we believe that you are who you say you are. Here's a key card or an authentication token. And so after authenticating and obtaining the key card, you can access resources across the hotel. So with OAuth 2, here's a simple version, but you're basically trusting Gmail and you kind of trust Yelp, and you want Yelp to have access to your contacts only. You don't want it to actually be able to access your email account and send emails on your behalf. So how it looks is you'll go to yelp.com, and instead of entering your username and password in, you'll click on Connect with Google. You'll be redirected to Google, accounts.google.com. They will ask you if you want to allow Yelp to access your public profile and contacts, and then it'll come back to Yelp, and then they'll go ahead and access those contacts. So I'm deliberately keeping this without many labels because I'm going to add labels as we go on. So OAuth's terminology is likely what makes it the most confusing. And like I said, I'm not an expert on it, but I know a whole lot more than I did a couple years ago. So there's actors, there's clients, there's authorization servers, there's resource servers, there's access tokens, and there's redirect URIs. So an actor in an OAuth flow is as follows. There's a resource owner. They own the data in the resource servers. For example, I'm the resource owner of my Facebook profile. I'm the resource owner of my Google contacts. There's a resource server. This is an API which stores the data that you want to access. there's a client, and clients in computer science in general is a very overloaded term, right? In this case, it's the app. It's not the actual user, it's the app that's making the request. And then there's an authorization server, so this is the main engine of OAuth. And the resource owner is a role that can change depending on the context. It can be a user, it can be a company. So if we switch those out, right, we have the authorization server up here, we have the resource server down here. When we're looking at something like Google, you can see that this will be like Google accounts, and this will be your contacts or your Gmail or whatever you're trying to access data from. So clients can be public and confidential. And remember, when we talk about clients, we're talking about apps. So this is a significant distinction between the two in OAuth nomenclature. Confidential clients, these over here, can be trusted to store a secret. If they're over here, they can't be trusted to store a secret because people can reverse engineer like iPhone apps and get a secret out of them. So when they're running on a desktop, or distributed through an app store, not a great idea. When they're running in a protected area where users can't access them, that's fine. I'm not so sure about the TV thing, though. I think people could probably hack those as well. But, oh well. Clients, one of the key components of clients is you have to go and register. You have to actually go on a website and register that client. So client registrations, like in the US, we call it the DMV, the Department of Motor Vehicles, where you go and get a license plate for your vehicle. And so the same thing with OAuth, you have to go and register that client. So if you've ever used JHipster and the OAuth support in there and you've used Keycloak, we've already done that hard part for you. We've already registered the client, we've already configured the different clients that you can use, and we've coded that into JHipster. If you've ever switched to Okta, you have to go and do some work on Okta to actually register your client there. So tokens are retrieved from endpoints on the authorization server. We have a number of endpoints. We have authorize. That's where you're originally redirected to. And chances are, if you're using OAuth, you're using Facebook sign-in, you're using Google sign-in, this is the initial endpoint that will be hit, but you won't actually see it in your browser because it'll hit that and then it'll redirect to somewhere else. And that sign-in form that you see on the next page, OAuth has nothing to do with that. Like, all it's saying is, hey, I hit this endpoint, people log in, and then I get an access token back. And then this is where you get the access token from. You can get a refresh token as well. You can use the refresh token to go get a new access token. And then you can also inspect the access token remotely if you want. You can do some validation locally, but you can also do it remotely. And then there's a revocation endpoint as well. So OAuth has two types of tokens. There's an access token and a refresh token. And by their nature, access tokens should be minutes or even seconds long, because what you want to do is you want to make it so you're never really worried about that access token being too long, because if it gets compromised somehow, like, you can't get a new access token without a refresh token. So you want these to be very short, and then refresh tokens are a little longer lived. And OAuth doesn't define the format of a token. So people often associate OAuth with JWTs and JOTs. That's there's like GWT and GWT. It's JWT and JOT. It's actually in the spec, spelled J-O-T. You don't have to actually have a JWT with OAuth. There's opaque tokens, that's down at the bottom here, and they're basically just secure random identifiers. It's just a string, right? It's like the hotel key card. There's really no information on there about who the user is. And then there's self-encoded tokens, and those are JWTs, so there can be a lot more in there, and people will typically stuff like user information and things like that into a JWT, and it's an option, but it's not really OAuth specific. So let's go through the flow again and see some of these terms defined. So we have a client, we have a resource owner, right, that clicks the connect with Google. You go to the authorization server, there's a redirect URI that you're specifying where you want the person to come back to. There's a response type of code. There's an authorization server that allows you to log in. And then it goes back to the redirect URI with that authorization code. And you specified, right, this yelp.com/callback, and then it exchanges that code for an access token, and then it uses that access token to talk to the resource server. There's some more terminology. Again, I said I think the terminology is the most confusing part. There's scopes, there's consent, and there's grants. So scopes are what you see on the authorization screen when an app requests permissions. I know this is hard to read, but this says like, you're authorizing Facebook to use your Twitter account. This application will be able to read tweets from your timeline, see who you follow, and follow new people, update your profile, and post tweets for you. If you ever see that on a consent dialog, you probably don't want to click OK. They also say down here that this application will not be able to access your direct messages or see your Twitter password. Whew. Right? I didn't know that was an option, but those are not good things to have in there. So it decouples authorization policy decisions from enforcement. It's about who owns the data and who gets to specify the authorization policy. And so one of the big problems with consent is just capturing that. And again, this is a bit grainy on this screen. But you'll see there are ways of limiting it. So some providers will actually say, you know, this person wants to access your account. You can say for 1 year, for 30 days, for 1 week, for 1 day. That's pretty slick. And then over here, you know, it'll say what it wants to do. It wants to, you know, see your network updates. It wants to send it messages and invitations. And then down here, like, there's more. So for the average end user, like, let's say my dad, right? He's 72. You know, he's been in computers most of his life, but if you give him a username and password dialog and it says enter your Gmail stuff, he's just going to do that, right? He's like, that works for me. If you give him something like this with all these different confusing options, right, it can be something that's a little tough for people to get used to. So that's been a little bit of a problem with OAuth adoption. So the other thing back here, I got to go through all the animation again, is at the end, if you logged into Yelp or you logged into Facebook, chances are you could go to your apps and see all the apps that you've authorized. And then what you'll do here is if you remove access, what you're doing is you're deleting the refresh token that they're holding. You can't delete access tokens. It's not a thing. They just expire. But refresh tokens, you can actually revoke them. And so then the person couldn't log in again with that same, you know, access token or get a new refresh token. And so let's go through with the scopes and consent defined. So we have a client, a resource owner, scope, you'll say profile and context, and then basically back here on the accounts.google.com, you will pass those through, and so it'll have to have on that API the ability for you to actually use these scopes, and you can lock them down that way. And then it all is pretty much, you know, similar from there. It talks to that resource server with those access tokens. Now, one of the biggest things that I learned is that my battery's about to run out, so I should probably plug it in. Front channels and back channels. So we've talked about the client types, the token types, the endpoints of the authorization server, and how we can pass, you know, that to a resource server. I mentioned two different flows, and that's getting the authorization and getting the tokens. Those don't have to happen on the same channel. So the front channel is what happens over the browser. Browser redirects to the authorization server, right? You log in there, you give consent if you're already logged in, and that all happens on the user browser. And then the back channel is a direct HTTP call from the client to the resource server to exchange the authorization grant for tokens. So these channels are used and for different flows depending on, you know, what your device supports. So this is a front channel flow. The resource owner starts the flow to delegated access to protect the resource, so they click on the button. Client sends his authorization request, right? You see some redirects happening in your browser. The user authenticates and consents, and then an authorization code grant or access token is returned to the client via the browser redirect. So this is an example of implicit flow. So this is how it looks raw HTTP. You'll do a get, and you'll put those scopes in there. You'll have that redirect URI in there, that response type, the client ID, and the state. And it'll come back with a code and the state, and so it's up to you to match these states and make sure they're okay. And then the back channel flow exchanges that authorization code grant for the token endpoint, and you can get a refresh token as well. And so how that looks is you do a post, right, to that token endpoint with the code, the client ID, and the client secret. So there was no client secret the first time, right? And then there's a redirect URI and a grant type. And then the return is an access token, which can just be a random string, right? An opaque string. Token type is bearer, expires in, and an optional refresh token. And then once you have that access token, you can make a request to the back end with an authorization header and hit that endpoint. So basic HTTP authentication uses the same authorization header. It just uses basic instead of bearer, and then it has a base64 username : password. And so let's look at this with the front channel and back channel. That front channel is happening on the initial request, and then this happens on the back channel, right? Exchanges that code for the access token. So there's a number of different OAuth 2 grant types. There's implicit. This is also called two-legged. It's optimized for browser only or public clients. So when I first started working on JHipster and it used OAuth, or it had OAuth baked in there, what they were doing was kind of like implicit, but the client secret was actually stored in JavaScript, hard-coded. And so when I started integrating Okta in, it was about 2 years ago, I saw that code and I was like, I can't work for this company and support this project and do things this way, right? So we changed it. But this is what people keep trying to add to JHipster is implicit flow, because what they believe is JHipster right now, the OAuth implementation, is authorization code flow, so everything's happening on the back channel, right? It's sending the client ID and the client secret to get access tokens. They want to move it to the front channel because what a lot of people believe is that if it's stateless on the back end, you can scale better. But if you do it this way with implicit flow, you're storing the access token on the client. And if you're storing any sort of data on the client, it's all good in development. When you go to production, marketing gets involved. They add the third-party scripts. They give it access in the CSP. Those third-party scripts might be able to access your access token and then access your API on your behalf. Though the authorization code is the gold standard, this is the one used most popular. That front channel flow still happens, but the back channel flow happens in a secure way from the Spring Boot server. There's also client credentials, which allows you to use it on behalf of an application or a different user. Back channel flow happens there as well, and it supports shared secrets or assertions. There's also a resource owner password flow. So this is a legacy grant type. It was only meant for native username and password apps, such as desktop apps, or you're working on Windows 3.1, right? And all you can do is a username and password. You can't actually pop a browser and redirect them and get that access token back and go back into the application. So people ask for this all the time at Okta. They're like, I have this app. I want to have my own form, right? I want to control everything, and then I just want to send a username and password to you. And that's great and all, but at the same time, if you let them do that, there's nothing in that app that prevents them from capturing your password, right? So you're kind of getting away from that delegated authorization problem. So don't do this if you can. If you have an app that you have to do it with, you can, and most OAuth providers will support resource owner password, but it's really the same thing as username and password and form-based authentication. There's also assertion, which allows the authorization server to trust grants from a third party, such as SAML. So you can have a SAML provider that comes into an OpenID Connect or an OAuth 2 provider. It does not support refresh tokens. And then there's also devices. So this has become popular with TVs, right? You'll get a message on your screen that says, go to this URL, enter this token in, and then it'll authorize you that way. So there's a number of different flows. There's 6 different flows. So if you're talking to someone that's an OAuth provider or they've built an OAuth server, you need to know how many of those flows have they implemented. How do you get consent from the client who's making consent? There's all these different things. So OAuth covers most of the different scenarios that you might need, and it adds a lot of complexity. So when people ask if you support OAuth, are they asking all of it? Are they just asking for authorization code flow? Are they asking for implicit flow? What is it? And so a friend of mine wrote this OAuthDebugger.com website that allows you to plug in an authorization URI, a redirect URI, a client ID, scopes, and state. And so you can see how things work if you want to test a server. For instance, with JHipster, if you want to test the Keycloak server and you didn't want to actually use JHipster, you can get an access token using this site, and then you could use it from the command line to access your API if you want to do that. There's also another one I recommend, OAuth.com/playground. This is written by a coworker of mine, Aaron Parecki, and allows you to choose an OAuth flow. Authorization code, PKCE, which is PKCE, public key, code exchange, implicit flow, which is the browser redirect, device code, and then OpenID Connect. So those are all options, and you just click through. It creates like Okta accounts for you in the background. You don't have to really do anything but click on buttons. And so the downside of everything is it causes a lot of developer friction. Managing refresh tokens, right? Knowing how to do that. Do you try catch? Do you wait for it to expire? Are you proactive? Are you reactive? Like, there's a lot of problems there for developers. And getting developers to do OAuth flows increases security, but there's just a lot of friction there. The cool thing is chances are your favorite language or framework, JHipster, has tools available to simplify things, right? And it's really not JHipster, it's more Spring Security. So there's a number of common OAuth 2 security issues. Too many inputs that need validation. What do you do for that? You add CSRF support. We have that in JHipster. Always use CSRF support, especially with the state parameter. Leaking authorization codes or tokens through redirects. Always whitelist redirects URIs. So this is one of the things that at Okta, we require you to have a full URL. You can't have a star or anything like that. But the Keycloak configuration for JHipster allows like localhost star, any port, anything. I'm surprised that Keycloak allows this, but they do. So it depends on your authorization server, but it's generally not recommended, right? Redirect or whitelist that whole URI, not just that one. And if you've ever used Okta and you see like a 400 error and it says your redirect URI is wrong, it's actually really easy to figure out what it is. You look in your browser, it's got redirect URI equals. You take that one, you put it in your app, you're good to go. Token hijacking by switch to client, so you can bind the same client to authorization grants and token requests. And leaking client secrets, obviously, don't do that. Don't put them in apps that actually go to the world and get distributed in app stores. There's several examples that have happened to most of the major providers, Google, Facebook, and Twitter. Twitter originally had their client ID and client secret in their native app in the App Store. People got it. They were able to act like Twitter, right, against Twitter's API, so not a good thing to do. Unbounded and bearer tokens, there's a draft specification for OAuth to do proof of possession, to actually say that, hey, this token came from this person that sent it, right, because that can obviously be bad. It's not cryptographically bound to the user, and JWTs help, but they're really just a string of characters at the end of the day. So there's key enterprise OAuth 2 use cases. All this is like for people that are into enterprise architecture. But it really makes it easy. For instance, at Okta, if you're using Okta, we use OAuth, but it allows you to basically add people, give them access to a bunch of apps, and if they quit or they get a new job or something like that, you can remove their access to all those apps. Like, those are key use cases of OAuth. Allows you to very easily provision people and deprovision people. So some facts: it's not backwards compatible with OAuth 1.0. Twitter only recently added support for 2.0. Interoperability issues exist because it's really not a protocol, but rather an authorization framework, and it's not an authentication protocol. So that's actually in the spec. OAuth 2.0 is not an authentication protocol. So when we say OAuth 2 login, it's not really login, because if you're using just OAuth 2, there's no information about the user. All you know is they have this string of characters, and if you validate it, yes, they can access that resource. So that brings us to 2012. Simple login, right? You can do that with OAuth 2. You can do single sign-on with OAuth 2. You can do mobile app login. You can do all this kind of stuff, but it's not an authentication protocol. So what happened is it became a pseudo-authentication protocol by Facebook Connect and Twitter. So what they did is they created a /me endpoint on their servers, and if you access that with an access token, you could get information about the user. So access tokens just prove the client was authorized, but they're opaque, right? They're just intended to be used by the resource server and not actually have users' information. So back to the drawing board, OpenID Connect was proposed as a solution for it. So OpenID Connect adds an ID token and a user info endpoint, a standard set of scopes, and a standardized implementation for the tokens, which is JWTs. So OpenID Connect is really just a thin layer on top of OAuth 2.0. And when I first started learning this whole stack, I basically tried to get rid of OAuth 2.0 as something that I would say and just concentrate on OpenID Connect. But really, without OAuth 2.0, there's nothing. There is no OpenID Connect. So they're very much related. This was all built by, inspired by Facebook Connect and SAML 2.0. Standard set of scopes there. Built-in registration, discovery, and metadata. So if you're familiar with JHipster OAuth implementation for JHipster 5, we had a number of different endpoints. Right? We had an authorization endpoint, a token info endpoint, and a user info endpoint. We specified all those. Now with JHipster 6, there's one. There's an issue URL, and what Spring Security is able to do is look at that URL and figure out all the rest of the URLs for you. So that's the discovery part of OpenID Connect. So it was created by Google, Microsoft, Okta, and it looks very much the same, right? You have a scope of OpenID email. Everything here is the same. The only difference here is you have an ID token, which has the user's information in it. And besides that, there's the discovery, right, where it goes to this well-known OpenID configuration. There's a token endpoint. There's JWKS, which allows you to do validation of JOT. And then there's also a user info endpoint where you can get the user's information. So this all looks similar, but you have a different scope here. Those are standardized scopes. Everything else is the same, except you have an ID token and you can get the user's information. So you can say, hello, Matt. JOTs, they have a header, claims, and a signature. You can validate them using this site. The grant types, we use authorization code flow in JHipster because it's the most secure. If you want to use implicit flow, you could probably refactor things, but then you'd have to do it in Vue, you'd have to do it in React, you'd have to do it in Angular. With the way we have it set up, all you have to do is on the client specify a URL to go to. Spring Security handles the rest, and then it's cookie based. So ID tokens should be used to create a session, and that happens. And then avoid using ID tokens as a stateless session token. So we're not trying to redo like what Spring Boot does in its sessions, right? We're just leveraging that for the cookies just like you normally do. We're just authenticating with the ID provider. For native apps, the basic recommendation is use AppAuth. So AppAuth is a project from Google and has many other contributors with SDKs for JavaScript, macOS, and Android. So I have a number of demos on github.com/octadeveloper for Spring Boot, for Spring Security, for Spring Boot with React, for JHipster, OIDC, and there's a whole bunch of different libraries you can use. Spring Security's OAuth is deprecated. Now it's part of Spring Security in 5.0 and 5.1, and we're using 5.1 in JHipster. And there's also a bunch of OIDC servers you could use. This Ori Hydra is pretty popular. You could use that instead of Keycloak, right? We use Keycloak by default in a Docker container for JHipster. There's also Kaz you might have heard of. And JHipster UAA is another option. That's just built with Spring Boot and their authorization server. So if you're seeing different dependencies when you're using UAA versus regular JHipster, it's because Spring Security 5.0 doesn't have authorization server support. So we're using a legacy library to provide that for UAA. So the OAuth specifications at OAuth.net. OAuth 2.0 servers, which was written by a coworker of mine, is at OAuth.com. So this is kind of a commercial one, but if you see down the footer here, this is the spec, right? OAuth.net. It's powered or supported by both Auth0 and Okta. So they're one of our biggest competitors. We're both sponsoring the site, both sponsoring OAuth. And so what does JHipster use? It uses that authorization code flow via Spring Security. They're the ones that do that. As far as Ionic and React support, right, there's two JHipster modules that do that. Both of those use AppAuth, and they use Pixie, so public key code exchange, so it's a little more secure than implicit flow. You can download this presentation. I'll give you a link at the end. All of these are links if you have the PDF, but you can also just Google those terms. These are all the JHipster blog posts I've written in the last 2 months, and they all use OAuth in some way or another. So you could read more about it there. If you go to developer.okta.com, I don't know why that turned blue, but tough to read. I blog there a lot. You can follow my team on OktaDev. There's also the JHipster mini book. I have 4 copies up here. I'll go ahead and throw them over there. Or the people that ask questions, why don't you have a copy? Unfortunately, it's JHipster 5, but really not a whole lot's changed in the mini book between 5 and 6, just like that issuer URL versus all those endpoints. But I wrote a real-world app that 21 points. And you can sign up at developer.okta.com. This is a great video. So if there's a video from this conference, and you want to share it with your colleagues about me talking, don't do that. Share this video from my buddy Nate. It's the craziest thing on our YouTube channel. It's got 257,000 views, over 400 comments, and they're all nice. I mean, how often do you see that, right, on YouTube comments? So that's pretty neat. He's a pretty great speaker. So keep in touch. I'm at raibledesigns.com, mraible on Twitter. I'll upload this presentation to speakerdeck/mraible, and most of the code I do nowadays is on Okta Developer and, of course, in JHipster. So may the auth be with you. Don't forget the stickers. Yes, question?
So I remember, so you said, in, I think in 5, you were able to select you want status or stateful authentication. So you're saying that's gone now?
We never had it in 5. And if it was in 4, it was probably the most insecure OAuth that you could use, which is with the client secret. So the JWT authentication is stateless, but that also stores the access token or the JWT on the client. So great, you're stateless, but you're less secure. And so what we typically recommend for people that are first of all worried about having a stateful backend, load test it. Tell if it's a real problem, right? And if it is, then you could probably use something like Redis for your session store, and then you can scale as good as you need to. Like, I don't know that stateless on the backend is all that people say they are. And a lot of people, like, they use JWTs for session tokens, and that's not what they're meant for, right? So that's how JHipster does the JWT implementation. Is like, hey, it's a session token, but it's really got way more information in there, and it shouldn't be used that way. So I'm just trying to, support the most secure thing in JHipster. So we do have some arguments in our issue tracker with people that are like, hey, I want the OAuth stuff to be stateless. Here's how I want to do it, and I'm always pushing back to be like, you can do that, but it's less secure. I'm not really willing to sacrifice, security for performance that may or may not exist. Like, the real problem is the front end and how fat that is, right? The back end scaling, probably not a problem. And I think that's it, right? 25? Yep. So, thank you. Enjoy the rest of the show.